Right, in our previous videos, we have run our analysis of covariance in two ways. Through our model here, we've used our dependent variable with quiz scores. Covariate was aptitude, and the grouping variable we care about was our type of method for teaching as our fixed factor. We did a type 1 sums of squares because we wanted to partial out the effect of aptitude, remove the effect of aptitude on group, but not the other way around. Now we're going to save some of our outcome as standardized residuals. I guess I had already clicked on that. Here's standardized residuals under saved. I'm going to go ahead and click OK, because really all I want is to get those standardized residuals out of this. I see our F values are the same as previous videos. For intro to analysis of covariance, you can see the previous two videos. So let's go ahead and look at our data. We see that we have now created standardized residuals. You can think about them like z-scores, a mean of 0, standard deviation about 1, and we've transformed what the residual would be like. What is our predicted quiz values here? Then they've been standardized. So we can take a peek at what types of assumptions we have. I'm going to actually start off with our Explore tab. I like to start with Explore. I want to take a peek at our standardized residuals. We can ask for both statistics and plots. There are several statistics we can get out of this. We'll take some of the defaults, and for our plots, we get a stem and leaf. I want a histogram. Let's go ahead and get normality plots as well. I just like to see the normal distribution. Although with 12 points of data, there's not much different than what the histogram is going to tell us. Under options, if you wanted to, you could choose select for missing data. And I'm going to go ahead and click OK. And we see that we have our basic statistics. We have a mean of 0. Our standard deviation pretty close to 1, and we have skewness and kurtosis well within the plus or minus 2 that we would expect for normality. And with such a small sample size, that's great. Often with small sample sizes, we are all over the place. So we also have a test of normality. This is not significant. With small sample sizes, you really got to be careful anyway. You know, the central limit theorem only works when you start to get around 25 or 30 cases, so you want to check normality here. You just can't ignore it with such a small number of cases. Another way of doing this is to look and examine the histogram. We can kind of see, well, that looks approximately normal, but with 12 cases, it looks like more data on this side than the other. And then we can look at the stem and leaf as well, which is given to us, which is just, I always look at it as a sideways normal distribution to see if that's coming up as normal. QQ plots are useful. The closer they are to the line, the more likely they are to be normal. You can think of our QQ plots as quantiles that have been plotted, and we examine them for normality. We get a couple other default things. We can explore this sideways. I'm going to go down to our box and whisker plot. I like to look at these because if we have outliers that are really extreme, they'll come up, you'll see a dot above or below these whiskers here. This is the main box and should be the median plotted, and sometimes you'll see values above or below, and that means those are potential outliers, candidates for removal, but that's a whole nother story that I won't go into in this video right now. Next, let's go ahead and graph our data. So I like to look at our scatter plots. We can look at this. I'm going to go ahead and look at group. Actually, that's in the right spot. And let's take our standardized residuals. And I'll say a couple things about independence here. First, many researchers, and I'm among them, think that the best way to control independence is to use random assignment. And that's true. There are measures and methods people use to try and account for the fact they couldn't randomly assign. That's fine. However, here is just one way to look to see whether or not things look like they're independently scattered and random around 0. And this does not look so bad on either way. We don't see a strong pattern. You see divergence from 0, but still random scatter around it in either case. So in our textbook, it talks a little bit more about this. And I would say that best practice is when possible, one should randomly assign. If not, one can still look at the residuals to see if there are some elements of random scatter around the value of 0. So let's go ahead and look at some of the other properties of our tests.